Hi, welcome back. In this video, we're going to talk about how to solve a quadratic equation using a different method. In the previous method, I used factoring as a way to solve it. Here, we're going to use the square root method. And I'll show you how to go about that. Okay? Now, again, we're dealing with equations that are quadratics, meaning the highest degree is a 2. We will do videos on how to solve cubic to the third power or something else, right? Now, we have different forms when we're looking at a quadratic. We can have it in standard form or we can have it in vertex form. And I'll show you how to solve different equations for different methods, right? Now, this method is an alternative to how to solve for x or another variable when it's quadratic. And I'll show you how you can go to the previous method if you prefer the other one, and how you can approach those as well in that format. Let's get to it. Okay, so here I have some examples, right? I want to write that my general equation looks like this in standard form. Notice how this equation looks like this one, except that it's missing this term in the middle. They are all missing bx in the middle, right? Technically, all of these equations just have an x squared, and an x squared. Whenever you only have one variable, you can actually isolate. You can isolate the variable because there's only one variable to work with. And for that, we're going to use PEMDAS backwards. We use PEMDAS backwards when you're solving or isolating a variable. As long as you only have one variable, you can always isolate it to leave it by itself. And we do it using SADMAP. We use PEMDAS when we're simplifying, right? So if you don't have an equal symbol and you wanted to simplify an expression, you would use PEMDAS. But since we're solving, we're going to go SADMAP. Now, let's say that you don't want to do it this method, and you want to use the other approach that we did earlier. Well, since there's something missing in the middle, you can always do this problem by inserting the value that you're missing. I have 0x minus 16. And if you prefer, you can use this method from our previous video, and you can multiply, cross-multiply to find your factors and all of that. As long as all of the values are on the same side of the equation, you will be able to use the method where you have your 3 columns, right? Now, we want to use a different approach so that we are comfortable doing different methods. Because ultimately, if any quadratic is presented to you, are you comfortable solving for x, regardless of the approach? So let's get started. I'm going to do PEMDAS backwards. I'm going to start with addition and subtraction. Notice how this problem has subtraction. To isolate the variable, I'm going to do the opposite of subtraction. I'm going to add 16. X squared equals 16. Check. Then I'm going to multiply and divide. Is there anything being multiplied or divided here? No. The next thing is the exponent. How do I get rid of the exponent? Well, the inverse of squaring is square rooting. By square rooting, I am able to cancel the squares with the square root. Now, the original problem was a quadratic, which means it has a positive side and a negative side to this symmetrical function. And now there's only one x. So whenever I square root the problem on both sides, I need to account for the fact that we have 2 possible solutions. 4 times 4 is 16, and negative 4 times negative 4 is also 16. So this breaks into my 2 solutions. X can be positive, or x can be negative. Let's try another one. Start with addition and subtraction. There's only one variable, so let's isolate it. Let's move everything to the other side. And start by adding 16. X squared equals 36. There's no multiplication or division, but I do have an exponent. And how do I get rid of it? By square rooting. I just need to account for the fact that there's 2 solutions, positive 6 and negative 6. X equals 6, and x equals negative 6. Again, you can move the variable to the left, create your 3 columns, just make sure you add a 0 to wherever you're missing, and you can have the other approach from our previous video. Let's try this one. We're going to gradually increase the difficulty on these problems, right? Adding and subtraction, just do the minus 42 to the other side. Plus 42. 6x squared equals 42. I'm almost leaving x squared by itself. Now it's multiplication and division. Since I'm multiplying by 6, I can divide both by 6. This allows me to isolate the variable. What's 42 divided by 6? 7. Now, the opposite of squaring is square rooting. So x equals plus or minus 7. 7 does not have a square root, and I can't simplify that radical. So here are my 2 solutions. Positive square root of 7 and negative square root of 7. The idea here is that since there's only one variable, I can do SADMIP. I can do PEMDAS backwards in order to isolate for that variable. Now, I'm not going to do all of these. I'll do this one in the middle, just for time purposes, right? I'm going to do PEMDAS backwards. If you would like to do all of them, feel free to do all of them. Give them a try, and then we can talk if you need some help. So, start with addition and subtraction. Move the 15 to the other side. 1/2 x squared equals 50. Check. Is there any multiplication or division? Well, I'm technically dividing by 2 here, so I'm going to multiply both by 2. I have 1x squared equals 100. Check. Do I have any exponents? The square. How do I get rid of that exponent? Do the inverse operation. Square root. X equals, remember, positive or negative 10. There's 2 solutions here. And 100 does have a square root. X equals 10. X equals negative 10. Remember that all parabolas are symmetrical, and they have 2 sides. This is going to be your plus 10, and then from the vertex, you'll have your minus 10. That's why there's 2 answers. You're welcome to move the 7, divide by 3. You're welcome to try all these examples, right? Now let's look at a different format. Notice how all of these look a little bit different. This one now has a parentheses. We haven't done an example with parentheses. We'll just do the parentheses part at the very end. Let's look at this scenario. Now we have no addition and subtraction outside of the parentheses and the exponent, right? And there's no multiplication or division, but there is an exponent that I can get rid of. Square root both sides. This could be plus or minus 2 equals to x minus 2. Because 2 times 2 can give you 4, and negative 2 times negative 2 gives you 4. Right? Now the last step would be the parentheses. Since there's nothing affecting the parentheses, I can get rid of it. And I can now move the plus 2 to the other side. So I have positive 2 plus or minus 2. How do I interpret this? Well, there's 2 solutions. X can be 2 plus 2, right? And x can also be 2 minus 2. And that results with my 2 solutions. Yeah. Because again, my quadratic, in this case, is crossing twice on the x-axis. Let's try this one over here. Yeah, as our last example. Let's start with SADMIP. Addition and subtraction. Let's add 12 to both sides. Check. Now I have, on the left side, a 3 that I got to look at. Multiplication and division. Since I'm multiplying by 3, how do I get rid of it? Divide both by 3. Now I have x plus 4 squared equals 4. How do I get rid of the exponent? Square root it. So now it's x plus 4 equals plus or minus 2. This is going to nicely cancel each other out because they're inverses. And now the last step is the parentheses. There's nothing affecting the parentheses, so I'm going to leave it as x plus 4. And now I can move this to the other side as my final step. My last step will always be the parentheses. And again, I have my two solutions, right? I have x equals negative 4 plus 2 and x equals negative 4 minus 2. That's how I get my two answers. So, please let me know if you have any questions. Don't forget to like and subscribe. And as always, we'll calculate.